2.2 Linear first order differential equations. In 2.1 we have learnt the way to solve first order differential equation with separable variables. Now, if the first order differential equation is linear, then this is the standard way of writing the differential equation. The standard form must be derivative dy over dx, where the coefficient is 1, must plus with p of x multiplied with y equals to q of x. In this case, p of x and q of x are functions of x or constants, while y here follow the dependent variable of the derivative, which is y. Based on this, we can find the integrating factor in order to solve this differential equation further, and usually we denoted it as Vx calculated as exponent to the power of integral of p of x with respect to x. Again, this p of x is the coefficient of y term here. Solving first order differential equation. Here we will see a specific example of first order differential equation to be solved using integrating factor method. Integrating factor method involves 5 important steps. The steps are listed here, so we will be solving this question according to the number of steps listed. As for the first step, we need to look into the differential equation given if it is written in standard form. First of all, the derivative must have a coefficient of 1. If the derivative having any other coefficient than 1, then the whole equation need to be divided by that coefficient so that it can be converted into 1. Next, we will be referring to the dependent variable so that we have the y term here, and the coefficient of the y is recognized as a px. So we have px, a function of x or a constant, as a coefficient of y. And on the other hand, right hand side, we will have another function which is called q of x, function of x or a constant. So let us check with our question here if it is a fit the first step. As we observe here, dy over dx, the derivative, having coefficient 1, and since the dependent variable is y, we are able to see y here. Therefore, the coefficient of y is called as px, and the 2 on the right hand side is our qx function. So this is our p of x, this is our q of x. So we are able to find out px as 1 over x, and be able to recognize qx as a function of constant 2. First step is over. Now let us move into step number 2, in which we need to find the integrating factor. Integrating factor denoted as Vx. V of x, in which we will be finding this using a formula exponent to the power of integral of px dx. So in order to find a Vx for this question, V of x is equals to exponent to the power of integral px of this question identified as 1 over x with respect to x. So if we solve this, Vx is exponent to the power of a ln x, and Vx can be simplified as x. Once Vx is identified, we can move on to the third step. Step number 3. In step number 3, we're going to multiply both sides of the dE with the Vx that we have found. Each and every term of the differential equation will be multiplied with the V of x. So, since our differential equation here in step 1, the derivative dy over dx will be multiplied with the x. So we will be having x times dy over dx plus this 1 over xy, 1 over xy will be multiplied with our vx, which is x, equals to the constant 2 is also need to be multiplied with our vx that recently found. This is a third step. Step number 4. Here, if we refer, the left hand side of the equation from the third step will be written as derivative d over dx of product rule of y vx. So, in this case, we will be having d over dx of vxy. vxy. So, we are having the term which is vx is x multiplied with y is the dependent variable of this question, equals to right hand side is qx multiplied by vx, qx2 multiplied by vx, which is x. So we have d over dx, x times y equals to 2x. We can enter into step number 5, in which step number 5, we will be integrating both sides of the step number 4. So integral of the derivative d over dx cancelled off, and we have a v of x y here on the left hand side of step 5. And for the right hand side of step number 4, qx vx, when we integrate, we have this as step 5. So integration of the derivative gives us x times y, the left hand side, equals to the term on the right side need to be integrated as usual. So if we proceed this, we will be having xy equals integration of 2x is x to the power of 2 plus a c as our solution.